Hiya there, folks. Root Beer here, wishing you all well. And we're going to start Part C of our 2012 Canadian Open in this video. We're going to be looking at C1. Let f of x equal x squared. Let g of x equal 3x minus 8. Okay, so got three parts to this question. Remember, we do need to show our work. That's why they have given us so much space. But of course, I'll be writing in my little notepad as usual. But we want to justify everything. We want to explain everything. So A part. Determine the values of f2 and g of f of 2. So this looks like we might be heading for some compositions. And in fact, if we read slightly further, B part would be determine all values of x so that f of g of x is equal to g of f of x. So more composition fun there. But we know f and g, so that won't be too hard. And then C part, let h be of x be 3x minus r. Determine all values of r so that f of h of 2 is equal to h of f of 2. I wonder if 2 is going to be an answer to B part. Just because they're talking about 2 a whole lot. Anyway, determine the values of f of 2 and g of f of 2. No problem. F of 2, well, what's f? It's x squared, so f of x, every time I see an x, I replace it with a 2. 2 squared, 4. It was g of f, or was it f of g? G of f of 2. G of f of 2, well, I know what f of 2 is, so this is g of 4. So 3 times 4 minus 8. This is also 4, and that's a little suspicious. So they're both the same value. And then determine all values of x. F of g of x is equal to g of f of x. Well, this isn't a problem, so f of g of x is just g of x all squared. So that's 3x minus 8 squared, and that's 9x squared minus 48x plus 64. G of f of x is 3 times f of x minus 8. So that's 3x squared minus 8. And I just want these two to be equal. So I need 9x squared minus 48x. This is just going to be a quadratic. We'll continue on the next page. So 9x squared minus 3x squared, we'll get 6x squared. The 64 and the 8 can be brought together to be 72. And then it's just minus 48x. I'm going to divide by 6 on both sides. 48 divided by 6 is 8x. And we'll get 12. Can we factor that? Two numbers that multiply to, x minus 2 and x minus 6. Right? Yeah. So x could be 2 or x equals 6. Those are the only possibilities, and if we wanted to, we could double check them. But I'm fairly confident in our work. It was just a basic quadratic, nothing really to worry about. H of x is 3x minus r, and now we want to do the exact same thing, but with f of h. And we actually just want f of h of 2. So I know f of 2 is going to be 2 squared, which was 4. That was from A. And we can even write that in if you want to, but I mean, it's such a simple calculation, I would just do it all over again. H of 2 is going to be 3 times 2 minus r, or 6 minus r. Did we want r to just be any real number? Yeah, okay, I didn't know if it was going to be an integer. And now f of h of 2 is going to be 6 minus r squared. So that's going to be 36 minus 12r plus r squared, and h of f of 2 is going to be 3 times 4 minus r, so 12 minus r. And if we want them to be equal, we just set them equal. And once again, we're going to get another quadratic. Bring everything over to the right-hand side. 36 minus 12 is 24. 11r, and then plus an r squared. This should be factorable. Oh, maybe it can't be. Two numbers multiplied. Oh, negative 8. Negative 8. That'll do it. I was thinking 12 and 1, but obviously that didn't work out. So r equal to 3 and r equal to 8. And if we check, this lines up with what we learned in B part because we start with r being negative 8. Or r being 8, sorry. It just turns out that 3 also does the trick. So 3x minus 3 or 3x minus 8 will give us what we want. And that was a pretty short way to start off question or part C of our contest. But there we go, and it's going to be a long time to scroll down, but then we're going to get to question 2, and I will take a look at that in the next video. Until then, take care and have a wonderful day.